Alright, this is the second installment, which is going to be, let's see, 2-6 for AT Math. Let's go ahead and open this up here. Let's go ahead and go to New Algebra 1 Notes, Chapter 2, 2-6, which sadly just says Notebook. So we'll see what that's about. Take a second for Smartboard to open up. Excuse me. Alright, and let's finally find what this title is here, which sadly I didn't label. It looks like it's 2-6, Rates, Ratios, and Proportions. Now, this is relatively easy for our AT Math students, but however, we'll cover it anyway. So go ahead and watch this video. Feel free to pause during you tries, and feel free to repeat any section as you need. Here we go. So we have rates, ratio, and proportions. A ratio, if you remember, is just a comparison of two quantities by division. So A to B, or A divided by B, that's all a ratio means. We're comparing one thing divided by another. When two ratios are equivalent, they are proportionate, or are said to be in proportion. For instance, an example of this might be 4/5, which really just means 4 divided by 5, which you know that 4 divided by 5 is 0.8. 16 divided by 20 is the same. If you divided 16 by 20, you'd also get 0.8, and 8 divided by 10 is the same thing. All these are proportional because they all turn into the same decimal or fraction. Moving on. Using ratios. The ratio of students to faculty members at Sandwich Middle School is about 1:20, give or take. If there are 200 students, how many faculty members are there? So, first thing you want to do is set up your ratio. Now to do this, it really doesn't matter which one's on top or which one's on the bottom, but for this case I put faculty on top and students on the bottom. Now I knew it was a 1:20 ratio, so notice here I have 1/20, meaning one faculty for 20 students. Now you can do that, but since I put faculty on the top, the other X has to be on top as well. Since I put students on the bottom, the 200, which represents students, if you notice, also has to be on the bottom, right here. Now, once I have this set up, I'm going to solve for X. Well, how? Well, there's a couple different ways. The first thing, let me go back, excuse me. The first thing I'm going to do is I'm going to go ahead, actually I'm going to just duplicate this or move it down here where I can get to it better. I'm going to do a thing called cross multiply. Now, all you have to do for cross multiply is you multiply the two numbers that are kitty corner from each other. So 1 times 200. Notice that makes 200. That needs to equal the other two that are kitty corner from each other this way. So 20 times X. Now to do that, what we do is to get X by itself. Instead of times 20, we're going to divide by 20. Now if you divide 20 on one side, we divide 20 on the other. Notice there that these cancel, leaving just the X. What you have here is 200 divided by 20 makes 10. Therefore, we're saying X equals 10. Now, another way to do that could be the following. Let me just move these out the way. Take this guy here. You could simply say, what number times 20 makes 200? And you could say, well, I'm going to say it's times 10. So you could put a little times 10 here, which is fine. But remember, if you do that for the top, you must also do it for the bottom. Or in this case, do it to the bottom, do it to the top. So if 20 times 10 is 200, 1 times 10 is also 10. And if you notice here, we have 10x, or what should be 10x. And there you have it. So if you could do it that way or this way, you decide. On your own, you try. Same scenario, except now there are 850 students. Go ahead this time, do the you try in your notes, go ahead and pause this video. Okay, hopefully you've actually paused it and you solved it. Let's see what you got. Well, I'm going to cross multiply myself. So I'm going to go ahead and take 1 times 850. And then I'm going to take 20 times X. Well, alright. So I'm going to go ahead and do 850 because 1 times 850 is 850. And I'm going to go ahead and take 20 times X, which makes 20X. Again, to X by itself, just divide by 20 over here, divide by 20 over here. These cancel. You know, a little trick about this here, 850 divided by 20 is a lot. So you know what I can do? Since they both end in a 0, I'll just cut out the 0. Now it's 85 divided by 2. Now 85 divided by 2 might be a little difficult, but remember that 85 is just 80 and a 5. Why does that matter? Because I'm just dividing by 2 here. Well, 80 divided by 2 is 40. And 5 divided by 2 is 2.5. That's how I do a little mental math in my head. So I'm able to get 42.5 there. Hope I'm right. Now if I'm not sure if I'm right, I'll just plug it back in. So take this original problem, and if I change the x to a 42.5, I believe. Let's take a look. 20 times 42.5. A little quick math in my head. 20 times 40 is 800. 20 times 2 is 40, so that's 840. And 20 times a half is 10, so I get 850. And 1 times 850 is also 850, so I'm good to go. You, of course, can certainly use your calculator where you need. All right, let's try another. The Chicago Bears win-loss record is usually 3 wins to every 2 losses, or rather 3-2. At least a true Bear fans like me like to think that. The Bears won 12 games last year. This was from a few years ago. But go ahead and see how many games it lost. So, let's put this together. If they win 3 for every 2 they lose. Now, you can put them either way. I'm going to put 3 on top. Now, you don't have to do this, but I'm going to put wins up here. This lets me know what the top is, in case I forget. Remember that when you're doing these problems, you may not be working in a nice quiet room where no one's bothering you. You may have some people trying to get your attention, or a TV might be going on, or people might be calling your name. So when you write things down on a sheet of paper, it's less likely you're going to make a mistake. It's less likely you're going to forget something. So I put wins up here, so when I look back and say, what's that 3 for? Oh yes, for wins. That makes sense. And then I'll put the 2 down here. Well, 3 is for wins, 2 is for losses, or lose. Okay, so that's the ratio. Now they're saying that in this example, the Bears won 12 games. Since I started up with wins on top, this wins has to go on top. So I put a 12 here. I don't know the losses, so I'll put an X. Now all I have to do is a little cross multiply. If you want, go ahead, work ahead. Pause this video and see what you get. Pause. Alright, hopefully you did that. Let's take a look what I did. I went ahead and took 2 times 12 and 3 times x. So 2 times 12 is 24. 3 times x is 3x. Instead of times 3, I'm going to divide by 3, and it looks to me like I'm going to have 24 divided by 3, which is 8. These cancel, leaving just the x. So 8 equals x. So 3 over 2, 3 wins every 2 losses. If you win 12, you probably lost 8. It should be enough for a playoff spot, if they actually played 20 games. But I digress. Moving on. Rates. A rate is a ratio of 2 quantities with different units, such as, let me move that there, 34 over 2 miles per gallon. In other words, if I went 34 miles and I took 2 gallons of gas to do that. Well, that's kind of difficult to understand. I mean, wait a minute. So for every 34 miles, you use 2 gallons of gas. Well, what does that mean? And so we're going to use a rate to find out. Rates are usually written as unit rates. In other words, a unit rate is a rate with a second quantity of 1 unit, such as 17 over 1. So if I would have taken 34 and the 2 here, if you notice this, and if I would have divided both by 2, remember, as long as I do it to the top, I got to do it to the bottom. So 34 that's a pretty poor looking divide sign, but bear with me. 34 divided by 2 is 17, and 2 divided by 2 is 1. Notice how I got my 17 over 1. Now, if I said to someone it's 17 miles to the gallon, well, that makes a little more sense because we understand what miles to the gallon means. Okay, so that's how far I can go on a gallon of gas. You may not care much about that now, but ask your parents, as gas currently is about $4.25 a gallon. It makes a bit of a difference. Or simply, I can write as 17 miles per gallon. You can convert any rate to a unit rate. How do you do that? Just take top divided by bottom. And by doing that, you will get whatever number you're going to get, and you can put per that 1 unit. I'll explain. It says here, see the text for examples of Takeru Kobayashi and his dog eating habits. So that's a reference for you, which would be, the page doesn't have it, but I'm assuming it's 2.6, so if you want to look at that, feel free. But moving on. thing called conversion factors. Now, a conversion factor is a rate in which two quantities are equal, but use different units. For instance, but use different units is called a confusion. I mean a conversion factor. See, I was trying to make a funny there, but I crossed myself up. So, can we name some? Let's see what we have here. It says see text for examples on using these plus. So, a rate which two quantities are equal but use different units. So how about this? Suppose I had miles per gallon. You just, in fact, the industry just uses MPG. My car, well, it's a beautiful Dodge 2008 Charger with a Hemi engine, only gets 19 miles a gallon, which sadly isn't that great. But if I converted miles, let's say, into feet, it's 5,280 feet in a mile. Well, now I could go ahead and take 5,280 times 19. That's a pretty poor looking 19, but again, bear with me. 0, 2, 7, 18 plus 7 makes 25. Carry the 2. I should have got my calculator, but that's okay. 45 plus 2 is 47. And then the second one, put the 0 down here. 1, that's nice because it's just across. 0, 8, 2, 5. 0, 2, 3, 1, 0. Approximately, looks like, I could say I go 19 miles per gallon, or I could say I'm going 100,320 feet per gallon. And I think that makes me feel a little better. So, my car gets 100,000 feet per gallon. So take that. Mileage standards. Next page. Now, looks here, we have cross product. So if you have an equal proportion such as A over B equals C over D, what I'm talking about here is that, remember how we multiplied before and it made the same answer? This is no different. Now, I realize A times D is AD, and C times B would be CB. Now, I'll be the first to admit we don't have an actual number. So I don't know what the numerical answer is, but this would simply be the answer that we have. Now, if you give me 3 of the 4 variables, I can tell you what the 4th one is. Also, because we crisscross, I call it crisscross applesauce. You're going to hear that a lot from me. It's just what I say. And finally, we have a scale. See, it sounds fishy, but a scale is a ratio between two sets of measurements, such as 1 inch to 5 miles. Now, usually it's separated by a colon to kind of put a separation. We'll say, okay, the 1's over here, and that's the inch, and 5's over here, and that could be the miles. So you could just say 1 to 5. Or in this case, or a 1/4 inch equals 1 mile. Although, that actually doesn't work out because it should be a 1/5 inch. I don't like that. We'll cross that out. But a scale drawing or model uses a scale to represent an object as a smaller or larger than the actual object. For instance, suppose I was using a microscope. Now let me use my superior drawing skills here. Alright, this would be the examine thing, and this would be the object, and this is the tray for it and whatnot. And you put something down here and you examine it. So let's say you're examining a molecule. 1 second. Hey boys, I'm recording. Shh, thank you. So we're going to examine something. Let's say it's really small. Let's say I want to examine 100 to 1. In other words, if something is only 1/100th of an inch in actuality, it would be 100 times bigger in my scope here. So it would be a 100 to 1 scale. On the other hand, you take a map. Let's go ahead and take a map of the United States. Now again, I'm using my little brush here, so I'll do the best I can. This is approximately the United States, the Great Lakes and whatnot. You get the idea. Well, let's say that actually in my little map here, that 1 inch, which would be right here, would equal 2,000 miles. So I'd say 1 inch dot dot 2,000 miles. Or if I had to convert inches to miles, if they were the same measurement, I could say that this little map here, 1, and I'd have to convert inches to feet. Oh boy, inches to feet to miles, which would be 12 times 5,280. We're going to say 1 to a lot. It'd be a whole lot of number. But the point is I could put that in scale as well. Now, I want you to do this for me. Actually, we won't even do it at home because we're flipping the class. So we're going to try this here. Now, if you want to get a jump start on it, you certainly can. we have page 117. On page 117, I want you to try 2 through 14 evens, which is only 7 problems. Try 19, 20, 23, that's only 3 problems. 30 through 33 is 4 problems. 38, 41 is 2. 48 through 51, which sounds like a lot, but that makes 10, that makes 20. It's only 20 problems, people. You can certainly do it. So, go ahead, thank you for watching. Go ahead and give that a try. And we will talk about that tomorrow morning. Thanks again. Bye.